Hello everyone, welcome back. 7.4 here with Mr. Havel. We're talking about systems of nonlinear equations. Okay, so wrote this down to save a little bit of time, but if we have linear is just lines, right? So you can have a line and a line. That's pretty much it. Nonlinear equations, it's a combination. You can still have lines, but a lot of other shapes. Circles, parabolas, absolute values, all that kind of stuff. Now, types of solutions, we've got a few examples here. Okay, so here we have a parabola and a line, and so with this, what we would say is that we would have, let's do blue, 1, 2 solutions. Remember, a solution when you have multiple graphs is where they intersect each other. On this second one, we've got a nice parabola and a line, but they only touch each other once. Right? So that would be one solution. And then here, this one's a kind of a cool one. We've got a parabola and a circle. So we'd have 1, 2, 3, 4 spots where they intersect each other. So 4 solutions. And our last one here, they're a little bit grumpy. They're not even close to each other. So this one would be no solutions. So the big thing is, remember, solutions for one graph means the x-intercept. For multiple means where they intersect each other. Cool. So for these guys, it says 1 through 7. We're going to solve the systems. So if you notice here on this first one, it asks you to do by elimination and by substitution. It's repetitive. We won't ask you to do this like on a test or something, but just kind of to show you what's happening and stuff like that. Okay, so by elimination, the biggest thing that you want to do when you have elimination is just make sure that they are lined up together, right? So we don't like that top equation because the y is on the opposite side. So what I'm going to do on the first one, I'm just going to move the y over. So we have x squared. I'm going to give myself a little bit of room. I'll explain why. Cool. And then the next equation here, we didn't have to do anything. All the variables were on one side. But what I did is I gave myself a little bit of room. You definitely don't have to do this, but just so you can kind of see who lines up with who. Cool. So that x squared is by itself. So we know we're definitely not going to eliminate the x squared because there's no one to eliminate him with. So what I would do is I would look and see, my recommendation is, yes, you can subtract here, but I always recommend have the same number, but opposite signs. So what I'm going to do is I'm going to multiply this entire thing by -1. And so if I do that, what happens is when I distribute in, it just changes the sign for all of these. And now I can add it straight down, right? So I have x squared minus 4x. The y's cancel, or eliminate, I should say. And then here we have -1 plus 1, so those guys go away as well. So now from here, what we're going to try to do is solve for x. So you might have to factor, bring stuff over, and then factor. You may not have to factor, but in this case, we have a GCF of x. Take both of them out, and so then our x we solve, so this x would be 0, and we'd also have 4. So those are our 2 solutions there. Okay, but if you look up here, if you notice, our solution is always going to be a coordinate point. So I need the x and the y portion of it. So what I'm going to do is I like to set up kind of 2 different columns. If x is 0, talk to me. If x is 4, what are we doing? Cool. Now you get to choose which one you want to plug it in here. It doesn't really matter. I might choose this top one, even though it's an x squared. It's almost solved for, right? So we look, y is equal to x squared plus 1. So now I'm going to plug that in. So if x is 0, y is equal to 0 squared plus 1. Or y is equal to 1. So one of my solutions is 0, 1. Now my other solution, I know x is 4, I need to figure out y. So y is equal to 4 squared plus 1, or in this case, 17. So those would be my two solutions, aka where they intersected each other. Now, by substitution, we do the same exact thing. We should get the same answers over here, but let's see the process. So by substitution, we want to get one of the variables by itself. Thankfully, because of elimination, I've already done that. So now what I'm going to do is I'm going to take this y value and plug it in for y. So I'm going to have 4x minus equals -1. And that minus is going to be the y value, x squared plus 1. Now when I go through and solve this out, I want to distribute in the negative. So I've got 4x minus x squared minus 1, and I'm going to bring this 1 over to the other side, so plus 1. Okay. Now, simplified a little bit, I've got 4x minus x squared. Those guys go away and give you 0. Now, I'm not totally in love with this look, so what I'm going to do is I'm going to switch it so that it is in descending order. And kind of the same process. Even though you look at this versus this, you're like, oh my gosh, they're different signs. Remember, we want it when I take out a GCF, we always want that first term to be positive, so let's take out a negative x, and then here x minus 4. And what do you know? X comes out to be 0 and positive 4. And then what you're going to do is, again, set it up. X is equal to 0, x is equal to 4, and we plug it back into that y equation. Y is equal to 0 squared plus 1, so 1, and y is equal to 4 squared plus 1, so 17. Okay, and we would write this as 0, 1 and 4, 17, which if you look, they matchy poo, and it makes us happy. Awesome. So again, most of the time, 99% of the time, you're just going to go through and solve by one of the two methods. Cool. So you get to choose on this one. Do you want to do substitution or elimination? I have to say elimination here, I don't know what I would do. Right, so it looks like a mess. So substitution looks like the way I want to go on this one. Okay. So what I'm going to do is solve this guy for x, get it by itself. So x is equal to -2y. Now plug that x into the second equation. So -2y minus 1 squared plus y minus 1 squared equals 5. Now we went through, we did a bunch of, we did the substitution part. Now the rest is purely just algebra, right? We're going to try to get the y by itself, solve it out. So we have -2y minus 1, -2y minus 1, plus y minus 1 equals 5. So a lot of distributing here, right? So this would be what, 4y squared, and then plus 2y plus 2y plus 1. So that is distributing in that first terms there, plus going for the second one here, minus y plus 1 is equal to 5. Okay. I know I want to get everyone on the same side, so let's go ahead and minus that 5 over right now. Now just be very careful as you're solving this out. We want to make sure that we get all the right terms when we go through this, right? So I've got a y squared and a y squared. And so that gives me 5y squared. Now I've got a 2y, a negative y, and a negative y. So that's going to give me a 2y. And then finally a 1 and a 1 and a minus 5. So that's going to give me a -3. So when you solve this, my hint is you're probably going to find answers that are not imaginary, I should say. So this should be factorable. Even though it's not super pretty, this should be factorable because we're not going to give you like a quadratic answer. Okay? You could still use the quadratic formula, but you're probably not going to get an imaginary solution. So in my algebra 2, what multiplies to give you 5? Those guys. Now the biggest thing is the outside and the inside terms need to combine to give you that, right? So we look what multiplies to give you 3. I'm going to take a wild guess and put a 3 and a 1 here. And so that gives me a 5y and a 3y. What would the signs need to be to give me a 2y? Well, this one needs to be positive and this one negative. Okay, so that'd be a negative and a positive right there. And so now my two y solutions are y is equal to 3/5, because I solved out this first one, and -1. Now if you notice, we just solved for y this time, whereas our last solution we solved for x. So if it was me, I would jump to my answer box, so I didn't get confused, and I would put these guys in right away in the correct position. Nice. Now we're going to use both of these, plug them back into there, and get the x values. Okay, so if x is equal to 3/5, y, or sorry, I'm totally backwards. See, that's why I put my answer first. If y is equal to 3/5, x is equal to -2 times 3/5, which gives me -6/5. So this would be -6/5. Then here, if x is equal to -1, holy cow, I just did it again. If y is equal to -1, x is equal to -2 times -1, or +2. Whew. Okay, and that would be your solution right there. Those two coordinate points, right? We'd have a circle and a line. So now number 3, if you look, we've got a couple circles going on, right? Now this looks pretty nice for elimination because they're all on the same side, they have each other, and so I'm going to look, okay, how can I have the numbers match but have opposite signs? So I'm going to try to keep it as small as possible. So I do notice right here, those guys, I could easily get them to match each other. If I multiply this entire equation by, I'm going to do this one by 3 and this one by -2. Now there's an infinite number of solutions of how you get these guys to match, but I would recommend, obviously, try to get the smallest ones and make your life a little easier. Right, so 9x squared plus 6y squared is equal to 105. Now, times the -2, so -8x squared minus 6y squared is equal to, what's that, -96. So I add them together, I end up with x squared is equal to, here, 9. Believe it or not, that's it, right? So I don't need to, I'm not totally done, but it's nice. I don't need to like factor or anything. So even though this problem started a little crazy, it ended really nice. So square root it. So x is equal to ±3. Okay. So you can, again, go to your answer if you want. You know you've got two solutions because x just came out as two solutions. So +3 and -3. Now, coming back, you get to choose either one that you want. I might not necessarily solve it for y because that takes a little bit too much work for me. But if I said, okay, if x is equal to 3, I might use the top one just because it's a little bit smaller. So 3 times 3 squared plus 2y squared is equal to 35. So 3 squared is 9 times 3, so 27 plus 2y squared is equal to 35. Subtract that 27 over, and so that's going to be what, 8? And then here, divided by 2, so y squared is equal to 4. Okay. Now here, I square root it, and I actually have more answers than I thought I would. So this is ±2. Okay, so I'm going to come back to my answer box and extend it. And so every time y is +3, it's got 2 values for y. So, sorry, when x is equal to +3. So x is equal to 3, it has 2, but it also has -2. Cool. Now if I go back, if you notice, this is where it's okay to do a little bit of a shortcut. The only difference I'm going to do is now I'm going to put, what if x is equal to -3? Right? Does anything else change with my problem? And the answer is no, because as soon as I square it, it comes back to be exactly that, right? So when I go through the process, I would be super happy if a student showed me this by doing something like this. It's going to match and still give you that plus and minus 2. Okay, so even for -3, you're going to have a +2 and a -2. So since they match exactly, sometimes this doesn't always work. You might see the answer written like this, ±3 and ±2. It's just because there's a plus and minus for both x and for the y. Okay, so either one's fine there. Cool. Okay, so number 4 here. 4 kind of leads itself well to substitution, in my opinion, because the y is already solved for. Okay, so y is by itself. So what you could do is plug this y into here. And so I get x squared plus 5 squared is equal to 25. Okay. Now I FOIL this guy out. Again, I might not write it out, but I wrote it twice. So from this I wrote 2 times, did the distributing, and you get x to the 4th plus 10x squared plus 25 is equal to 25. Now let's bring over that 25 and combine stuff. So I'm going to put x to the 4th first, and then I have plus 11x squared, and then when I bring the 25 over, I end up with 0. Okay. Thankfully, this makes my life quite a bit easier, right? So now I can take out a GCF, so x squared plus 11, and I solve each one. So this first one's not bad because x is equal to 0. And this one here, we solve it, but if you notice, when I solve it, I get plus or minus I root 11. Okay, we're just looking for real solutions here. Okay, so we don't want imaginary solutions. So all I want is real. So we get to pay attention, or we get to ignore that part, right? So here, that's nice thing. My answer is 0, comma something, and so the y portion of it, I plug this back into the top. So y is equal to 0 squared plus 5, aka 5. You can also do that through elimination if you want. There's an example on the notes through elimination if you would like to see that. Okay. Here's a few more examples coming through here. So number 5. It looks a little bit different, right? So if you look, we haven't really seen this where the x and the y are attached to each other. So this one definitely leads its way towards substitution because there's really no other way to eliminate. We don't have an x and a y in the second one to eliminate. So what we do is solve for either one. It doesn't really matter. I see that x is by itself here, so I might just do x. Okay. You don't have to, but I just thought might be kind of nice. So plug that into here. So negative 12 over y minus 2y plus 14. Now the trick here is, in order to get rid of that fraction, I want to multiply it by its denominator. All right, and so what I'm going to do is I'm going to go through and multiply everybody by y. So if I do y times this first fraction, I'm just left with negative 12. Y times the second, negative 2y, so negative 2y squared. And then y times 14 is 14y, and then 0 times y is still 0. Cool. Now once I've done that, that's kind of the only trick about this problem. And then I want to reorder it and factor and solve, right? Ooh, sweet. GCF minus 7y plus 6. Get that factors down. So something like a y minus 6 and a y minus 1. Cool. So my two solutions here, if y is equal to 6 and if y is equal to 1, what would my solutions? Notice how I didn't get a solution from that first GCF because he doesn't have a variable attached to him, right? So if if y is 6, then x is equal to negative 12 over 6, which is negative 2. And then here, if y is 1, x is equal to negative 12 over 1, which is still negative 12. So when you write the answers, just be very careful that you put them in the correct order. So negative 12, 1. Nice. Okay. Number 6 is kind of like number 5, where it's just like, holy smokes, there's just a lot going on. Unfortunately, there's nothing that really matches each other in either equation. Yes, there's x's and y's, but there's no just x down in the second equation. There's no just y in the second equation. So you get to solve it, okay? So for this one, again, it doesn't really matter. Sorry, little arrow. So it doesn't really matter what you solve for, but I'm going to just solve for x. Okay, in this problem, they'd be very, very similar. So x would be, I know that it's squared, so I'm going to write it twice. So 1 minus y, 1 minus y, plus 1 minus y times y minus y squared. I know I'm going to bring it over, so I'm just going to do it now. Okay, so there is just a lot of cleaning up to do right here, right? So a lot of distributing, that kind of stuff. So for this first couple binomials, we've got one, it'd be a minus y plus y squared, plus distribute this y in, so it would be y minus y squared, and then the next two are by themselves. Now obviously just be very careful with how you do this, but look for all your y squareds. It's kind of nice, one of them cancels with one of these, so I'm left with negative y squared. Now my just y is negative y, positive y. So again, one of those sets cancel out. And then I've got a 1 and a 5, so plus 6. Okay, and so equals 0. So now if you want, you could do two things. You could either bring everyone to the other side, or you take out a negative GCF. It doesn't matter. So then you have y plus 3 and y minus 2. And now solve it out, right? So now if y is equal to negative 3, if y is equal to 2, we need to figure out x. X would be 1 minus negative 3, which is 4. So we've got, what, 4 negative 3. And then here, if y was 2, x would be 1 minus 2, which is negative 1. So we'd have negative 1 and 2. Awesome, cruising. So, in my opinion, even those started kind of crazy, they kind of finished a little easier. Holy smokes. Okay. Now, what do you do with this problem? Right? So it looks super duper crazy. We're looking over it. And then hopefully out of nowhere, you notice both of the y's disappear. Holy smokes. Thank you, math. 8x plus 8. Right? So this one definitely starts out as the craziest one, but it really goes quick because those y's cancel themselves out. Now take out a GCF, we've got x squared minus 4x plus 4, and so 2, we got what, x minus 2. So this is really nice because my only x value is 2. So if x is 2, now this is where it's really hard to get around this. Maybe it started super pretty, but may not end super pretty. So I'm going to plug this back into the original equation. I'll just plug it into the top one because they're so similar. So we end up with 2 squared, which is 4 minus y squared minus 4 times 2, which is 8, plus 6y minus 4 equals 0. Now I've got to clean this up, right? So negative y squared, my y's, I've got what, 6y, so plus 6y, and then 4 minus 8, so negative 4, negative 8 equals 0. I would take out a GCF and factor it, right? So if we factor it, we end up with y, what would that be, like a minus 4 minus 2 type of thing? And so y comes out to be 4 and 2. So given with the one x value, it comes back and gives you two y values. So I would have 2 and 4, and then also 2 and 2 as my solution. Okay, so the 1, 2 gets repeated with our two y values. Awesome. Okay, we're cruising along. Just a couple more problems, and then we're done. Now you've already kind of seen this problem. Okay, so you've already seen this problem, but now there's just words to it. So it says here, find the length and width of a rectangle whose perimeter is that and whose area is 21 square feet. Okay? So now we just need to put this into a system, right? So area of 21, perimeter of 20, it says length times width, which I'm going to call x times y. Cool. So the perimeter, we know is going to be 2x plus 2y is equal to 20. Your area is x times y is equal to 21. Okay? So now we want to figure out potential values for the x and y. So if you look back in your notes, this looks really similar to like number 5 is a very similar problem. So it doesn't ask for one necessarily, so I'm going to just solve this. Maybe this time I'll say y is equal to 21 over x, and then substitute that in, right? So we have 2x plus 2 times 21 over x. I know I'm going to bring everything to one side, so I'm going to subtract the 20 over now. Now I want to get rid of that x in the denominator, so I'm going to multiply everybody by x. So I end up with 2x squared. Right here it gives me 42, and then the x cancels, right? So the x cancels, and then minus 20x equals 0. Get everything in the correct order. Plus 42. Take out a GCF. What's that, like a 21? And then factor. Cool. So what do we got, like an x minus 3 and x minus 7? So our two values is if x is equal to 3 and then if x is equal to 7. Right? So if x is equal to 3, your y value, plugging it back in, would be 21 over 3, so 7. So we could have, oops, not x, that's what we're trying to find. 3 and 7 would be one option for your length and width. Your other one would be if x is 7, your y would equal 3. So you could have a length of 3 and a width of 7, or a length of 7, width of 3. And that would be your two options there. All right, last one here. A planet's orbit follows this path, described by 16x squared plus 4y squared is equal to 64. A comet follows a parabolic path of something like that. Y is equal to x squared minus 4. Where might the comet intersect the orbiting planet, right? So we definitely don't want to run into each other. So here, intersect, that's a big word. So that means I want to find the solution for the two. And so since I already have y equals, it sets me up really nice for substitution. So I'm going to do 16x squared plus 4 times x squared minus 4 is equal to 64. Distribute in. 16x squared plus 4x squared minus 16 minus 64 equals 0. So what do we got here? Like a 20x squared minus 80 equals 0. which really makes it nice because now I can take out a GCF, 20, and then x squared minus 40 minus some, believe it or not, is 4. And so here you can solve this, or if you notice it's a perfect square, x plus 2, x minus 2. Right? So here we would say if x is equal to 2 and if x is equal to negative 2, what would my y equal? So y would be 2 squared minus 4, which is what, 0? And then if you notice on this other one, holy smokes, sorry, I totally missed this. I was like, man, this problem was a lot easier than I remembered. It's because I forgot this guy, right? So sorry about that. Let's go back and correct it real quick, right? So there should be, I'll do it in so that you can correct it. There should be a squared there. And so this part right here, we've got to change. And so this is going to be, if I FOIL this out, this is going to be what, x to the 4th minus 8x squared plus 16. So then distribute the 4. So I should get 4x to the 4th minus 32x squared plus 64. Okay, I apologize for that. It'll clean up here pretty quickly though. So if you notice, the 64s go away. Okay, and so I'm going to erase. We don't have the 80. So this right here, we have 20 with those two, and then now instead of again, I feel like it's getting a little late for me. That says x squared there. So by itself is the 4th is 4x to the 4th, and now my x squareds go together and give me negative 16x squared. Okay, and so when I'm going to do the same process, take out a GCF, which is going to give me what, 4x squared, and then inside here I get x squared minus 4, which, believe it or not, gives me very similar results, but the only thing I forgot is x is equal to 0, and then x is equal to plus or minus 2. Okay, even though it gave me similar results, definitely make sure, I apologize for the wrong method at the beginning there. So we'll say if x is equal to 0, this one makes my life kind of easy, 0 squared minus 4, so this one would be negative 4. So one of my solutions would be 0, negative 4. That's where they could intersect. Another one could be 2, 0. That could intersect. And then this last one, if you kind of remember back to another problem we had similar to this, whenever it's squared, you're going to find out that they come out to be the same thing. So this one would be what, negative 2, 0. Cool. Sorry about that little blunder there. But I hope you enjoyed. Tell a friend, and we'll see you next time.